All right, so problem 3, it says we have a machine and a manufacturing company, and it's programmed to fill shampoo bottles such that the amount of shampoo in each bottle is normally distributed with a mean of 0.6 liters and a standard deviation of 0.04 liters. Let the random variable A represent the amount of shampoo in liters that is inserted in a bottle by the filling machine. Okay, so part A, we have that a bottle is going to be considered to be underfilled if it has less than 0.5 liters of shampoo. So to determine the probability that a randomly selected bottle of shampoo will be underfilled. Okay, so we essentially want to find the probability that A is less than 0.5. And we're told that we have a normal distribution where the mean is 0.6 and the standard deviation is 0.04. So we're essentially just looking for the probability to the left of 0.5 in this normal distribution. So we can use our calculator. We would just use normal, this CDF function. The lower bound, we would go from negative infinity to 0.5. And then we would enter our mean. That's 0.6 and our standard deviation is 0.04. Depending on your calculator, you may not have to memorize it. If some of them are much easier or user-friendly to use because it tells you has options to fill in for the mean and the standard deviation. So negative infinity, we enter a super large number. So 0.5, lower bound, upper bound. Our mean 0.6, followed by our standard deviation 0.04. So that's the syntax. And we're going to get 0.0062. So it's a very small probability, less than 1%. All right, so part B, or part B 1 and 2. So after the bottles are filled, they are placed in boxes of 10 bottles per box. After the bottles are placed in the boxes, several boxes are placed in a crate for shipping to a beauty supply warehouse. The manufacturing company's contact with the beauty supply warehouse states that one box will be randomly selected from a crate. If 2 or more bottles in the selected box are underfilled, the entire crate will be rejected and sent back to the manufacturing company. Okay, so part B, we have that the beauty supply warehouse manager is interested in the probability that a crate shipped to the warehouse will be rejected. And we're going to assume that the amounts of shampoo in the bottles are independent of each other. So part 1, defining the random variable of interest for the warehouse manager and state how the random variable is distributed. Okay, so essentially we have 10 bottles, and we want to, find the probability that 2 or more of those bottles will be underfilled. So let's have X represent a randomly selected bottle that's underfilled. And so we want to find the probability that X is greater than or equal to 2. Now, we want to be more exact. We want to find that we get at least 2 underfilled bottles from 10. And the way you want to approach this is you want to just think of 2 possibilities. Either the shampoo bottle is underfilled or it's not. It's either underfilled or not. It's not. We don't really care necessarily about the amount. We care about whether it's underfilled or if it's not. So then we're going to have X will be a binomial random variable. Binomial random variable where with 10 trials, so we'll have n represent our trials. So 10 trials, our p-value will be 0.0062 because that's the probability that x will be underfilled. And again, we have already found x greater than or equal to 2. We could say that usually we use NPK for, so we put k is equal to 2, or we could say k is greater than or equal to 2. Depending on what type of variable your calculator or your textbook uses, it may be something else. But in my textbook, we use NPK. So to figure this out, let's set the probability that x is greater than or equal to 2. Now, this is going to be equal to 1 minus the probability that x is less than or equal to 1. Now, the reason I'm doing this is because the calculator that I use only does calculations for less than or equal to. So the function doesn't actually calculate this inequality. It will calculate less than or equal to inequalities. So I'm going to use this format or this form. So what I do is 1 minus, in my calculator, it's the binomial CDF function, where n is 10, p is 0.0062, and then the k is 1. And let's see what we get. Let's do 1 minus when distribution CDF is cumulative. So the syntax is n, so comma p 0.062 followed by k, which in this case will be 1. If you have the later versions of this calculator, again, it'll usually have entries where it tells you explicitly where to enter the number of trials, probability, and k. For these ones, you just have to memorize. And we'll get about 0.00167. Now, the good thing about these problems on your AP exam is that as long as you show, clear work, they're actually not too strict on how you write this stuff out. These problems are usually the toughest, and the probability problems are usually the toughest. So as long as you're writing your work out clearly, so they know you're not just guessing and getting an answer correct by luck or, cheating, then you're fine. All right, last part. To reduce the number of crates rejected by the beauty supply warehouse manager, the manufacturing company is considering adjusting the programming of the filling machine so that the amount of shampoo in each bottle is normally distributed with mean 0.56 liter and standard deviation 0.03 liters. Would you recommend the manufacturing company use the original programming of the filling machine or the adjusted programming of the filling machine? Provide a statistical justification for your choice. Okay, so since they want to, reduce the number of crates that get rejected, they want to, have a lower chance that a randomly selected bottle of shampoo will weigh less than 0.5 liters. So we're still going to find the probability that, the bottle will weigh less than 0.5, but in this case, we have a normal distribution with a mean of 0.56 and a standard deviation of 0.03. So we still use our normal CDF function, just like the first part. Lower bound, negative infinity. Upper bound will be 0.5, followed by our mean, 0.56, and our standard deviation. Let's see what we get. And 0.02275. Now, if we look at what we had originally, we had 0.0062. So this probability is higher than the original one. So then we actually don't want, we actually would recommend that they don't change the specifications to match this, because your probability of getting underfilled shampoo bottles is actually higher. So we would just say something like that. We recommend keeping the original settings. Since the probability of a bottle being underfilled is is less. And we kind of would say that, also this, then it would make sense that a crate would, this would have a larger chance of being rejected, because since each bottle has a higher probability of weighing less than 0.5 ounces, then obviously picking two that weigh less than 0.5 ounces would, be more, would have a higher, you would have a higher chance of that. That's all there is to that.